Alright, today I'll be talking about the geologic history of Madison and the University of Wisconsin campus. The beginning, tectonic plates. So, the North American plate is the tectonic plate that Madison is located on, and it contains sandstone, shale, and other limestone sediments. It is thought to have come here all the way from 10 degrees south latitude, very far away. And as it came here, it collided with other tectonic plates, forming geologic features such as aquifers and other stuff like that. And in addition to that, there's also been millions of years of erosion, and this caused a lot of other geologic features to occur that we see on a daily basis here in Madison. Now, this picture here is just a sedimentary rock deposit in Lakeshore Nature Preserve, just to show some of the sediment deposited from the tectonic plates. All right. And here is an old topography map from the UW Geology Museum. Now, the red lines on this map, they represent shorelines of the lakes, and the blue here, this represents bedrock, and the other colors they represent other types of bedrock, sandstone, shale, stuff like that. It's just a cool little map showing the old pre-glacial topography of Madison. All right, Yahara River and Pleistocene. So this area was thought to extend around 50,000 years ago. There are a bunch of sandstone and limestone caves. With the Yahara River was at the bottom of a river valley, and there was a bunch of like sandstone and limestone caves formed on the edges of the valley and leached into the river, giving a bunch of nutrients, stuff like that. In addition, there was the Green Bay Lobe, which is the glacier that slid over Madison, formed topography. This extended to between Madison and Verona, forming the terminal moraine there. And when it melted, forming a bunch of glacier lakes that flooded Madison. And these lakes were thought to be around 15 feet higher than present-day Lake Monona. The formation of lakes and land. So, Lake Yahara was initially formed when ice dams blocked the Yahara River. Eventually, they failed, melted, caused recession, and this recession led to the four biggest lakes in Madison today. So, Monona, Mendota, etc. The glacier lobe, ice sheet, smooth and longitudinal topography, as I said on the last slide. One notable example of this is the formation of the drumlins that resulted from this, Bascom and Observatory Hill. Pretty neat. And in this picture here is just the terminal moraine that I mentioned on the last slide, showing the extent of the glaciers between Madison and Verona. You can see in the line right there. Glacier transportation of rocks. So when the Green Bay Lobe was sliding over Madison, it deposited a bunch of sediment. These are referred to as erratic rocks because they're non-native to the Madison area. The largest of these were referred to as haystacks. It also deposited metamorphous and igneous rocks too. Now, this picture here is showing the topography of Picnic Point here. It's just a pretty neat picture. These are my references. Thank you so much.